Okay, you need to be lower. And I can switch over. All right. Hey everyone, I hope that you're having a great week so far, and that your Thursday is okay so far too. It is just beginning for me, but I'm looking forward to what we're going to be doing today, which is implementing that spatial partition chapter that we read yesterday into GGEZ and Rust. Specifically, I want to sort of like see us like going through it and actually like see it in action. It's one thing to just sort of read through the chapter, convert the code over to JavaScript. I can get a decent understanding that way, but actually like having it work for real, that's where I think the real understanding comes in. What I'm gonna go ahead and turn on the line bot so that way you can highlight lines, and let's also come into here and set up our main everything. So GGEZ, our crate name here is Spatial Partition Rust, and our project name is Spatial Partition in Rust and GGEZ. And that's it for there. Something else that I would like to do for this. I almost forgot. We need to bring in GGEZ. Okay, so for this, I want to also pass in context. This is something I put into my to-dos to like update this entire thing, so that way it just does this automatically for me, but we don't have that right now. So we'll just pass in mutable context, mutable reference to a context, which we already have right here. And that's pretty much the only change I need to make in this file. I'm gonna go ahead and go create our live.rs. Nope, not that. I can just doglive. And the big difference here in new, we're gonna take in a context, which is a mutable reference to a context. And of course, I'm not doing anything with it right now, so it should give me a warning, but no errors. And I should be able to run this as well after it's... Right, we have a lock because I beat Rust Analyzer. My tea is a little bit too hot for me still. And here we are. Okay, so we have the basic sort of game running here. Now, I mean, we're not really making a game for real. I forgot that I need to update that. I am going to write that down. Figure out a way to turn off, if the pen works, turn off that NVIDIA game overlay thing. That pops up when I start playing. I mean, I like the fact that it pops up in one way because, I mean, it kind of shows, hey, I'm making a game. Like, you know, it recognizes that it's an actual game that I'm making. And the other side is just annoying. So, okay, so we've made that, we actually have like the very basics of the game going for us. So we can go ahead and check what are the first like basics that we want to do in this sample code here. And we're going to want to create a unit. So what is a unit? A unit is going to be our X and Y. Now this one is going to take in a reference to the grid. And I'm not sure we're going to be able to do that quite properly. It sounds to us like what unit is a game object. That being said, we can create it as a struct unit just to sort of keep it very similar to what we have here. So let's create a unit.rs. So pub struct unit. Before we go any further, let's go ahead and mod that. And now that I've created, let's see, now that I've done that, I believe, yeah, we're gonna get our proper sort of like help from Rust Analyzer in here. So just telling us that we're not using it, and that's fine. So what do we need in here? We need an X and a Y, and it wants us to store a reference to the grid. I'm really concerned about that. Now that being said, we could probably get around this with like an RC or an arc. So let's start with an X, which we know is going to have to be an F32, and a Y, which is going to have to be an F32. The grid, yeah. This is going to be an instance of the grid so that we can call methods on it. I'm thinking more we're going to want to pass the reference in when we use it as opposed to just having it stored internally. Which I think is going to be a lot easier. You know, that being said, if we do need to in a constructor for unit, put something in there and like add to the grid, we could pass it in here and just not store it internally. I think that's the idea, so we're just not going to store the grid internally. We're also going to have a move method here. So let's implement unit. So we're going to have a pub function new. In new, we're going to take in an X, which is an F32, and a Y, which is an F32. I don't know right now that we need to do anything with the grid. We don't seem to be doing anything with the grid. And we're going to return a new unit, I believe. And so we're going to return a unit that has an X and a Y. And we're also going to have this move. So public function move, which is going to take in an X and a Y. And I guess it's just going to move to that location. Okay. So mutable self, X, which is an F32, and a Y, which is an F32. And my guess is, because I don't think he I don't think we ever actually implement this, do we? We just sort of like talk that, hey, we're going to be able to move this. This would essentially be self.x equals x, self.y equals y. Just like replace our positions with whatever is passed in. Move is a reserved keyword in Rust, so we can't actually use ourselves. So let's just say like move unit. That'll work. All right, so then we're basically just arguing, hey, unit doesn't exist in here. Like, you know, we're not using unit, so that's a problem. All right, so that's unit struct. Then we're gonna have this grid. The grid is gonna have a array of arrays to like mark that grid. And then we're gonna want the number of cells and the cell size. And then we can use that to sort of like do our inserts and do our gets and everything else that we need to do. So let's create our grid next. I'm going to do mod grid. I'm going to create a grid.rs. Okay, so in the grid, we're going to store cells, and we're also going to store num cells and cell size. That's like the three things that we have. We could have constant inside of this entire file, which, I mean, I think would be fine, but it sounds like we're only going to need it inside of this, this class. So we don't really have a constant in this way. So number of cells, cell size, and the actual cells itself. So I could actually make this smaller so we can see a little bit better what's going on. So we have number of cells, which for right now, we know that these are going to be used to create the size of this. I'm thinking this might have to be a U size, but I can't remember. Rust will yell at me, depending upon what it actually needs to be. Let's see. Number of cells. We also have cell size, which is a U size. And then also the cells itself. Now this is going to be interesting. And this is the reason why we need this to be a constant, isn't it? So we need to actually make this out of here. So we're going to do const. Number of cells. Can I convert this really easily to all caps? No. I removed the caps lock. Actually, did I? No. Yeah, I removed the caps lock. It's now escape on my key, so I don't actually have the ability to write all caps easily. So you're going to be a U size, and we're going to set you equal to 10. The number of cells, and then the cell size. So this is going to be interesting. How do we know what the number of cells that we want is? I guess we're going to have to do like some manual calculations here. We come over to the main. Actually don't know what our size is. We can figure this out through, let's like finish this off and I'll like adjust the numbers. Const cell size, size equals, we'll just say 20. We don't need to store U anymore. Now for cells, we're going to use these two, and we're going to say, okay, we're going to have an array, and the array is going to be the size of number of cells. But what are we going to store inside of it? We're going to store an array, right? So an array of an array, and this one is going to be size of number of cells. And then in here, we're going to have the a unit, right? We're gonna put a unit inside of here. So we're going to need to actually use super unit like that, and be able to say that we're going to store a unit and then it's going to be the number of cells as well. Is that correct? Our inner array, so we're going to have, right, two arrays. Number of cells, this, and then this stores units that are number of cells. Now, the problem that we're going to run into pretty quickly is we're going to end up having it's going to want us to do this as like a reference to the unit, and that's not going to be happy with us. We're going to have to do anything like something tricky with like an RC, or an arc or something like that to pass the unit in, give ownership of the unit, because we're not going to be able to store like a linked list of unit to like the next unit very easily here. And so perhaps like unit ID would help. And if we do a unit ID, we could then do a hash map, insert into the hash map, put the ID into here. Still doesn't matter. We're still not going to be able to have a linked list to get that. I think we're going to end up having to be not quite as efficient as this code and have a vector of unit. And it's just going to be a single vector. So 1. Now, is it going to let me do that? Oh, it is. The thing is that vectors can grow. So I'm really surprised that it lets me use like a single vector of units. Wait, that's wrong. I want this to be number of cells. There. That's what I want. We're going to have 10 vectors along the x-axis and 10 arrays along the y-axis. So each cell is really just going to be a vector of these units. And they can be owned inside of this, inside of the grid. So that way we can just loop through and then have them do like the double loop inside of them. It's not quite as like awesome as what we have in here, but it's also like Rust won't allow us to easily do what we're doing in here either. And I think that's all we need to do right now with our grid. Now, something that I do want to do is actually draw our grid out. That would be really nice. So let's actually implement that. So implement the grid so we can like visualize it and see what we're doing. So let's first start with pub function new. We're not going to take anything in. And we're going to return a new grid that has cells, which is an array. So we have to create the array multiple times. So what is this? This is going to be an array of an array, semicolon, number of cells. Then in here, it's going to be a new vector, and we're going to make that empty. And then we're going to say that we want number of cells equal to that. Okay. Oh, and I forgot to tell you what we're returning. We are returning a new grid. The trait bound for unit copy is not satisfied. So we need to go implement copy for this struct. Derive copy. And we need clone too, don't we? Yeah, clone is not satisfied, so we need both copy and clone. Now about you. If the copy trait is required, let's see, so... Oh, interesting, okay. So you... I have clone and copy in there, but you don't know. Let's do that. Do I need to restart the... Let's try running it and get the real errors. That's what I was afraid of. Okay, so copy is not implemented for the vector that holds a unit. And unfortunately, vector is something that I don't control. So I think what we should really do here is to move on is let's not make these arrays. Let's actually just make these vectors. It's not going to be quite as nice because we're not going to like just assign the we're not going to assign the memory like ahead of time and only keep to that memory, which I mean is a little bit unfortunate. But what we can do here is say that we're going to have a vector of a vector of units, like that. And so in here, we actually want to create the vector to be of the right size. So we're going to want cells to be equal to a new vector. Let's make this mutable. And then we're going to want to loop through the number of cells downwards, so the y's essentially, and push them into this vector. So we're going to do for this is going to be our, do we even care about this? Not really. So it's like this in 0 dot dot number of cells, and then I'm going to want, what are you upset about? Mismatch types. Okay, so you need to be expected struct vector unit. What? I'm not returning this. That's interesting. You're that. Okay. So then let me actually finish this and see if like Rust Analyzer is just freaking out right now. We want to push into cells an empty vector. So we're going to do cells.push another empty vector, like that. And then we're going to just pass cells into here. Yeah, okay. It was just freaking out because I hadn't like finished the code yet. So this will create now our grid. So we have 10 an array that holds a bunch of arrays, and then those inner arrays can hold a unit. Of course, there's nothing in there right now, but I don't necessarily think that that's a huge problem. Now we can use this new immediately by coming over to library. We will say use grid. Let's actually store the grid in here. It is going to be a grid. Select grid equals grid new, and then we'll store it in here. Now, next thing I want to do, I want to draw this grid out. I'm looking at unit. Well, so to me, that means I'm gonna want like a bunch of lines. So I'm probably gonna want a line. We can have like a horizontal line and a vertical line, maybe. Like two meshes for that. So let's inside of here, let's grab and use GGEZ. So we know we need, we're gonna need context to build this mesh. So context, we need a game result. We're gonna need graphics to draw it out. So So in graphics, we're gonna need the mesh builder. What else do we need? We know we need draw params. I think we need a draw mode and a draw param. We probably need something else that I'm not thinking of right now. And so let's do a horizontal line mesh, which is a type mesh, and a vertical line mesh, which is a type mesh. All right, so now you're gonna be upset at us, and that's fine. Let's go ahead and create our meshes down here. So let horizontal line mesh equals mesh builder new. All right, what do I want? I want a line. Okay, so it's gonna be points, like a series of points of where we're beginning and where we're ending. I believe that that's how it works. Creates a new mesh for a line for one or more connected segments. Yeah, exactly. So I could create like weird shapes, I think, but I just want like one to begin, one to end. So in this case, I want, and this almost like is weird. Could I just make a line that just goes like that and just like one single grid that connects them all? That would be really cool. But if I do like a single horizontal one, we're gonna start with a reference to an array. We do need points, so use GGEZ. Oh my gosh, come on, type today. And algebra, point 2. Okay, so point 2, new, we're gonna create 0.0 and 0.0. This is a horizontal line, so then we're gonna have to go to the end of the screen with the next one. Now, in order to do that, I'm gonna need the context. Did I bring that in? I did. So context, which is a mutable reference to a context, and we're gonna need let's see, this is gonna be the screen width, screen height equals, I realize I don't want to cover chat just in case. Okay, so screen width, screen height equals, we're gonna do graphics, drawable size, pass it in the context, and now we have the screen width and the screen height. So we can now say that our point 2 goes from 0, 0 on the x-axis to the screen width on the x-axis. And actually, you know what? I realized this is 0, 0, 0, 0. I had it correctly. And then we're gonna have another point 2, new, which is now gonna be screen width on the x. So screen width, and then 0, 0, 0, 0, 0 for the y for that line. And then we'll just repeat that line down when we draw it. So that's a horizontal line. Width. I'm thinking we probably want to make this like 1.0 if I can get away with it. Color, we can make this white. Come on, mouse, work with me. White. All right, and then I need to build this. What are you going to return? Oh, you return a game result. So I'm going to want to question mark this, then I can build it, pass in the context, and then I can question mark that and semicolon. What that means now is that we can't just return a grid, we have to turn a game result that holds a grid. And now that's gonna make our horizontal screen mesh happy. And so we want to do the exact same thing, but now with a vertical screen mesh. Let's just repeat that. Let vertical line mesh. Okay, so new. Our points are going to be similar but different. We're going to start with 0, 0, 0, 0 for that top left, and we're going to go down to the bottom, which is going to be 0, 0 for the X, and then screen height for the Y, and everything else is going to be the same. So we're going to save that, and we're going to add you into here. So this is going to be the horizontal line mesh and the vertical line mesh, and then we're going to wrap the grid inside of an OK to make everything happy here. Apparently we did not need draw mode or draw param for lines, so I will get rid of those. All right, so that's happy. Let's go make the rest of the app happy because we just sort of changed things. This function now takes context. Also, we need to question mark this because it's coming up with a game result, meaning that we need to return a game result here. So game result of a game state. And that will make us happy here. Well, no, we need to return this with an OK. Okay, that will make us happy here. But of course, in the main file, we are getting in the game state, and we can't question mark this because this is the main file. So this is now where we just say, hey, look, if this ends up happening, I want you to just crash the system. Go ahead and do that. And now we have 20 errors, 20 warnings, but no errors. And I think that's fine. Let's cargo run this, make sure that everything is going well. Okay, it still is. Next up, we want to draw that grid to the screen. So in grid, we're gonna have a hub function. Let's do like draw. We're gonna have like probably a draw here. Let's do a reference to self. We're probably gonna need to bring in context. Let's mute context. We're gonna need to return a game result, but this doesn't need to actually return anything inside of it. And for right now, I'm not gonna be like reaching in and drawing anything inside of these. It's grids right here. I just want to draw the grid lines to sort of like show what we're working with. And what does that mean to us? Well, the game result, let's see. So we want to loop through the number of cells here. And then for each cell, draw a line on the right or the left. Like just probably one of those, right? We want to draw, well, we probably want to draw a line on like the left-hand side. We'll just draw at 0. So we'll do a graphics draw context. The drawable is going to be self dot. Let's do the top down. It's like top down. So that's going to be our horizontal line. So self dot horizontal line mesh, and then here's our draw params. Did I get rid of them? I did. Our draw param, we're going to create a new one, and we're not going to create a destination for it. We're just going to leave it exactly as is, and it's going to be fine and happy. And we're going to question mark and semicolon because that's going to actually draw it out for us. At the end here, we're going to have to return an OK. That will just make that happy in the meantime. And now let's loop through the number of cells that we have and draw at the bottom for each of the cells. So we're going to say for. We are going to need to like create this count because like some kind of index count, some variable to hold like what number we're on, so we can multiply the cell size for this. Let's see. I don't know what to call it right off the bat. It's not like index. Maybe we'll just do count. So count equals, or count in, 0 dot dot actually, if I do 0, it's gonna multiply by 0, right? So I probably want this like 1 dot dot. And then it's gonna be the number of cells. Let me think about that. So number of cells, I'm gonna multiply 1. So like we're gonna start with 1, multiply that by the cell size. So that will go do the first one 20 pixels down. And then the second one will be 2, so that'll be 40 pixels down. I think that's right. That should be right. So then we're gonna do graphics, draw, hand it the context. The drawable is gonna be the reference to self.horizontal line mesh, and then the params. So draw param new, and then we're going to give it a destination. And so for this specific destination, we want you to go 1 section down. So that's going to be a new point. So point to new. The X is going to be 0, 0 always because we're doing a horizontal. So we just want to move the Y, and that's going to be count as an F32 times, actually in this case, you know what? We could just do count times cell size, and then take this entire thing, and then as an F32. Question mark, semicolon. And that should make that happy. So we should now have, I need to run it first. That would be helpful. Okay, so we have this public function draw in our main library. Under draw, we're now going to call it. We're going to say self.grid.draw. Pass it in the context, question mark that. Okay, and so we're seeing the horizontal lines, and this is how far we're getting down. So we need to actually be a little bit more specific about like how, like what the size of the grid really needs to be. Because if we just say like this is 10 and this is 20, that's not really all that great. That being said, we can figure out exactly what we can do our calculations by inside of a grid here. We're getting our, where is it? Here's our screen width and screen height. Let's run a debug. Screen. Actually, I think I can get away with just running this again. Running you again, like that. And I should now get a printout of the tuple that is the size. So it's 800 by 600. So if I want, let's say I want 10 cells. So 10 divided by this, I'm gonna want 80 cells to, let's see, 800 by 600. I want 80 cells to the right and 60 cells down. That seems not optimal. I want this to be a square, don't I? And if I want it to be like actual squares, let's change our arena to be maybe like 800 by 800, and then we can make these 10 by 10s. So then we want 80. Maybe to like show it off a little bit more, we don't have to do like 10. If we're doing 800 by 800, maybe we want like 8. So that would be, if I want 8, I want 100, them to have 100 size, I think. And then I want 8 cells across and 8 cells down. So if I do that, and then in our main, we're gonna do a little bit of trickery here. So use GGEZ. Apparently we don't need the context. We totally need the context. It needs. I'm surprised that it doesn't. It says we don't need the context there. Okay, so use GGEZ. Is it under event? Is it under config? It's under conf. Window mode. I want to say window mode. And then when we're creating this, okay, context builder new. Before we do a dot build, I'm going to do a dot window mode. And then here we're going to do a window mode. I think I have to create. Come on, give me. Okay, can I get like a default? There's no new. Okay, I need to go look this up, unfortunately. Okay, so let's go to creates.io and take a look at GGEZ. And specifically window mode. A builder structure containing window settings can be set at runtime and changed with graphics set mode. Okay, set the default window size or screen resolution. Okay, so I could just do dimensions, I think. It takes. I have to do a dot for dimensions, so I have to create a new one first. Is there like a default? Okay, so it implements default. So I think I can do default like that, and then dot dimensions. And then in here, it's certainly not acting like it. Well, okay, it can find it. Okay, never mind. I can do this. So here I want 800 by 800. All right, so if I do this and I save and I rerun this, we should get an exact grid of like 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Okay, this is exactly what we wanted. So there's our grid. Now let's do the exact same thing, but along the vertical. So in grid down here, we can use this same loop because it's going to be the same count because it's a square. So we're going to do another graphics draw. And it doesn't look like we actually need to do this first one. So we can skip that. Okay, so graphics draw, we're going to pass it the context. We're going to pass it a reference to self.vertical line mesh. And then we're going to get a drop param new. We give it a new destination, which is point to new. We're going to start with the X is going to be different this time. This is going to be the entire count times cell size as F32, and then 0, 0, like that. What are you upset about? Set the destination point. This function takes one argument, but two arguments are supplied. Oh, I put you in the wrong place. I want you there. All right, let's see if we have a real grid now. We do, okay, so we can now visualize our grid, and then when we see things going into it, we should be able to see like which grid box they're gonna be in, or at least which grid box they should be in. We'll have to figure out like how to actually verify that they're in the right box, but that might be a later problem. All right, let's go back into here. What is next? So that we've just created the grid. All right. Now in Unit, they're gonna want us to do this like previous next. I'm gonna ignore that. We can't do the linked list very easily inside of Rust. I know it's possible to do them, it's just not easy. Okay, so the first thing we need to do is make sure the units are actually placed into the grid when they are created. We'll make a unit handle this in its constructor. So when the unit gets created, we give it the X and the Y of the position of the unit. And we're gonna have it call add on the grid. And then we're gonna have this add method defined like this. It's gonna have to figure out where to go in the grid. It's gonna take that by the unit's X position, divide that by the cell size. And it's gonna have to like convert that into an integer. So like, you know, go down. Add to the front of the list for the cell that's in. Well, we're just going to now append it into the vector that it's in there. So, all right, so I think it's gonna be slightly easier than this, but pretty much exactly the same. So we're gonna have in the grid an add. We're gonna mute self here. And then we're gonna take in a we're gonna take in a unit. That's gonna be interesting. This is suggesting that the unit gets added in through this. I'm almost thinking that we want the grid can insert the unit. So let's have okay, if the grid's gonna add something new, it's just gonna take in the X and the Y. F32 and the Y, which is gonna be F32. It can create the unit and then add it in there. I think that might be a little bit easier. And then it will, like properly put it in. We're not gonna return anything. So the first thing we wanna do is create our unit. So we're gonna do unit new, pass it in the X and pass it in the Y. And there we go, we have a unit. But we need to insert this unit into the grid as well. So we need to figure out which cell it's gonna go into, and that's where this comes in. So that cell X equals, okay, so the horizontal X that we want it to go into is going to be the X here. So it's gonna be X as a U size divided by cell size. And that will figure us out. That will figure out like what the index is supposed to be. And that cell Y equals Y as U size divided by cell size. Okay, so now we have the X and Y coordinates, and then the last thing to do here is just to insert it into that vector of vectors. So then we're gonna say self dot cells of position Y first. So cell Y. And then from that, and I think we've already created these out, right? Oh, then we want to push that in. So that's the correct one down, and then dot push in the unit. Is that correct? I don't know if I like this, because we're not gonna know, we're not gonna be able to like get this unit back, are we? Not very easily. We want, see if I can. I redid my camera position, so this might not be the right exact. Ah, it's close. There, that works. And you're able to hear me. Might be a little bit loud, but at least this works, I believe. So I think we're running into a problem here. We have our array of arrays. Maybe the better way to draw is actually of the array of arrays. So I have an array, and inside of here I have an array like that. But I think the problem is I've just created an array of empty here. And I want to create these with like all of their sizes already out there. So something like that. And that's a problem, because not all of them are going to have anything in it. We just want them to be able to put something in there. And null is not really a thing we can do in Rust. What we can do is options. So we could use an option for this, and maybe that's what we were running into initially. I don't think I was thinking about it properly. So we have this cells.push and then just this empty vector. If I was to redo this really quickly, let's try this. We have an array, so that's that top down, and we know that this is going to be of an array of size, number of cells. And then the inner one is I want this to be an array of option units. And is that correct? No, I'm going to want this to be an empty vector of units. That's okay. Number of cells. Is that correct? So what I really want from this, back to where's the whiteboard, is to replace these and just say, like, let's say it's like 3 by 3. I want this to be maybe really small. Like that. And that replaces the linked list. Because instead of like just a single unit sitting in there. Now, is that correct? So this is, if I want like 1, 1. So this would be position 1 down. So this is 1 on the Y, and then the X would be 1 here. And so if you're in that cell, there could be many of you in here. So this is a vector of, points, of units. And this is a vector of units, and this is a vector of units. So I think this is correct. I might have to go one deeper. So I think this definition we had correct initially. I think it was when we were building it out that we were incorrect with doing this. So down here in the grid, when we're creating this grid, it's going to be upset at us until we figure this out. So we're going to start with let mute cells, and let mute cells, vector. Oh, it can't be a unit because we don't know that there's going to be an in here. So this has to be an option. Right, that's what it was. Option unit, like that. Because, let's see. Is that true? Or is it that, like, we can't clone the vector? That's what it was. We couldn't clone the vector because it doesn't know how, like, the size of it the size of it. If I do actual vectors of this, I think I can set their size ahead of time, or I could just do. I think I have to undo my undo, which is unless any of you know that I can do it this way. So we have the vectors going down and then the vectors going right. And inside of that is the vectors of the units. I think this is what we have to do, is three vectors, not 2 vectors. And that's only because of like the linked list, like the lack of a linked list. Which is a little bit unfortunate. Okay, so if we have this, then we have cells, we have a vector. We loop through this with the number of cells, and that's creating the initial vectors going down, and this creates them going along the side. And I want to push in a vector that really has a vector like that. Do you make... Yeah, okay, that's what makes it happy. Yeah, this is gonna be fun. So now we have the cell Y and then a position cell X. And then we can push in the unit. All right, so that then adds our unit into into like the grid area. So that's fun. So let's maybe like actually implement this and try to add something in. So in our main library, we're gonna do a here. Let's create this to be mutable. I'm gonna do a grid dot add, and then let's just say like I don't know, 255.0, 255.0. So that adds it into the grid. When I draw the grid, I also want to draw all of the elements in there. Utsby, good morning. Sorry if you missed the reason why you were mowing the lawn, but is there a reason why the grid isn't a fixed array of arrays of vectors of units? Is your world size expandable? I tried to do a fixed arrays of vectors of units, but it wouldn't let me implement copy and clone for the vectors. And so maybe I just did it wrong. Or maybe there's something else like I was failing to do properly. And that might be something that like off screen I might just go and try. But okay, we implement that there. Now I want to draw all of these out. So first of all, let's implement a draw on the unit. So we're gonna have a pub function draw. Self. We know we're gonna need a context. So let's go ahead and make sure we add that in. Use GGEZ. All right, so what do we need? What do we know we need here? We need a game result. We need a context and a game result. So context and a game result. We need GGEZ. We need a let's see. Oh, and a graphics. And then inside of graphics, we need a drop param. Is there anything else we need? That just may be it. So then in here, this can be a mutable reference to a context. We're gonna return a game result of essentially nothing. And then we're gonna do a graphics, not drawable size, but draw. Pass in the context. Pass pass it in. Okay, so we need, when we create a new unit here, we do need a mesh. So we need to deal with that as well. So we need a mesh builder. Is this right? Probably. For right now, I'll have these hold their own meshes just in case these are like separate things. But we could easily like hold this mesh and pass it in and like have the grid just know all the different meshes and like basically have a type in here. But for right now, we'll just do a mesh, and when we create a unit, we will create a mesh and store it in here. So we'll have a mesh, which is a type mesh, which means that when we create the unit, this now needs to return a game result of unit, which makes that really happy. Okay, so let's do let mesh equals our mesh builder new. We're gonna make this just a circle. Oh, draw mode, I forgot about that. This one needs a draw mode. Okay, so draw mode, let's just have it be a fill, a point. Okay, so for our point, like where is this gonna be? Let's just make this 0, 0, and then we'll have it like move around based upon that location that we have here. So that means we need use GGEZ, and then an algebra, point 2. Okay, point 2, new, 0.0, 0.0. Our radius, we're just gonna have all of these be like 5.0. A tolerance, we can have this be something like 0.5. I don't know if that's gonna be visible very much. And color, I'm thinking for right now, we can make this white, but maybe in like a future stream I have a plan for that. So we'll bring in a color here. So that color equals color new. And red is really easy to see on stream, so we'll just do 1.0, 0.0, 0.0, 1.0. And we'll use the color here. Okay, so then we're gonna build this mesh, pass into context, semicolon. We'll store this in here. And of course, we need to pull in the context so it's happy here. So context is needle reference to a context. All right. So you're happy at this point in time. When we go to draw this, we can't derive copy and clone anymore. Okay, so when we go to draw this now, we want to self.mesh, and then the draw param new. So that gives us the default here. And then we're going to send it to a destination, which is a brand new point to new that has self.x, self.y. Hi, Chantilly. Good morning. And then that's what we're going to return, is just this. So it's going to draw itself out. Now, we have a couple problems here. Let's go and fix these. Function takes 3 arguments. So when we create a new argument, we do need the context. That's not really a problem. Okay, so we're going to add in the context here and then pass that in there. Now, mismatch types, expected struct unit, found enum of a result. Okay, so we need to question mark this, which means we do need to do a game result and handle that there. A convenient result tile, let's see. So in place, oh, right at the end of here, we need to return an OK, like that. All right, so now we're happy with this. Then let's see, when we add, we need to question mark that and then pass it in the context. So that should make you happy. Okay, no more errors. That being said, we're not drawing out yet because in grid, we need to now loop through all of the cells and then draw them out. So that's gonna be fun. So let's loop through that initial set of down. So and this is gonna be the Y cells in self.cells. Okay, so we have our Y cells. Now in the Y cells, we want to get the X cells. So for X cells in Y cells. And then now we're gonna get a vector of the, now we have a vector of all of the units and we want to draw those out. So that's gonna be for unit in X cells. And we're gonna call unit dot draw. We have to pass in the context and question mark this. Okay, self.cells. Cannot move out of self.cells, which is behind a shared reference. The thing is, I don't want to move out of it. Move occurs because self.cells has type, center vec, unit, which does not implement the copy trait. Consider iterating over a slice of the vector's contents. Okay, I can do that. So self.cells. So it's a reference to this is what it's suggesting. Okay, let's see if this draws out our one spot. Oh no, panicked. Out of bounds. The length is 1, but the index is 2. So in grid line 75. Okay, so self.cells of position. So what did it try to put in here? Let's debug this. I don't know if I can debug multiple things in here. Can I do like X and Y like that? Oh, I can. Okay, perfect. Can I like go one further and do self.cells? And like just have them all here. Unit doesn't implement debug. Sure, let's implement debug for unit. Derive debug. And we'll pass you a reference to that so you don't move out. All right. Let's run you and see what we got. So in self.cells here, we have an array. So here's our vector, our first vector. And the side of that, so this is the going down, and this is the first Y, and then the X. Is that, am I correct with that? So that, okay, these are the Ys. And then these are the X's. Wait, so Y, see here, Y is 255, X is 250. Oh, I'm doing the wrong one. I need cell X. Cell X, cell Y. That's what I need to figure out. Okay, so we got 2 and 2. So our cell Y is first. Bear Duda, good morning. Our Y is first, so we're gonna do a position 0, 1, 2, right to here. And then our X is also 2. So 0, 1, 2. So 1, 2. Okay. So this inner one, we need it to be of the right number of... We need this to be a vector with a certain size of things. And I'm not... let's see. Is that one more layer of vectors? No. That's not a layer of vectors. Do I have to do like an option for it? I basically have to make these... It's like in there, in here, inside of here, I need like a whole bunch of more vectors, don't I? Because like the y is 2, so 0. 0 is this one. 1, 2. And then inside of that, I need to go 0, 1, 2 inside of here. So I need 1, 2. I need 3 of these, at least. That's unfortunate. When I create this, I need you to have like a certain number of them. And I think that there's a way to do that. I want to say, can I do vec vec new reserves capacity for at least additional more elements to be inserted given vec t. The collection may reserve more space after. I don't think that's exactly what I want. Set length forces the length of the vector to new length. This is a low-level operation that maintains none of the normal invariants of the type. New length must be less than or equal to capacity. The elements at old length, new length must be initialized. Okay, so I could try to make... Wait, does this have to be unsafe code? I don't like that. So I need to repeat this vector, this internal vector, how many times? Okay, so this one I want to repeat. And n times, don't I? So can I say like unsafe for one? I think that was a reference to FFI. Oh, you know, you might be right. Maybe I don't need to worry about that. But here, can I? Oh, I forgot the name of that one. Was it like set? Hold on, let me try this again. Dot, there is set the length. It's like set length, forces the length of the vector to new length. This is a low-level operation. Okay, so let's do that. Set length. So then for this one right here, set length to be number of cells. Will you work now? Mismatch types expected a struct of standard vec found nothing at all. What? Cells equals this. Vec will dynamically resize. I know, I'm just trying to like insert into like a very specific one, and it's not working right for me. Cells that push. And I wonder if that's where I need to create... I may just want to rethink about this as I have my X and Y grid with like options or nones in them to begin with. And then I can like actually create the grid. And if there's a vector in there, I just push it in. That might be the best way to do this. So let me switch back to here and like go over my thought process for this. Basically, let's say we want our grid. We want this grid to be a square. So we want really like elements here, here, and here. We want these to be vectors too, to hold like n number of whatever is inside of this grid point for us. The problem is that we need to create these. So I need to loop through and create an empty vector for each one of these points. So I think I'm just missing the internal loop, aren't I? Like I'm missing another for loop, I think. So we have a for loop down, and then we push in this array. We create this array, and then we have to create this number of things inside the array, and then push it into here. That's, I think, my mistake. So we have, we're looping, doing the initial loop here. I'm trying to do this all in one line. I think this is a problem. Let's just sort of like reset here. We want to create the horizontal vector. So let's just do horizontal vector. So like, we'll call this like the X cells equals a new vector of this. Now I want to do another loop inside of here to push into like another empty vec inside of these X cells. So for this is going to be basically X in so let's do 0 dot dot number of cells. This needs to be immutable X cells, and then I can do X cells dot push an empty vec inside of here. Okay, I think this is going to work. Now at the end of this, I can now push into cells. So we're going to do cells dot push X cells like that. I think that's what I need. And so now if I save and run this, what are we going to get? Oh, there we go. It works. Perfect. And so here we're drawing our elements to the screen, and we can see now that we have all of these cells. We have 8 per, it's a square grid that we have. What is number of cells? Shouldn't they be width and height? Number of cells. So basically, I'm saying we have 8 cells wide and 8 cells deep. So that's that. I have that like defined up here at the top. Sing Hashish 18. Good morning. Hello. Now, of course, I printed this out before we put the unit into it, but that's fine. So let's go ahead, come back to here. We don't need this debug anymore. But this is really cool. We've now got this printed out. And so I don't have much time for this, but we actually know that it's in the correct cell, which is really, really, really cool. Now, if I want to, if I wanted to print out like only specific cells or anything else. Oh, so it's the side size and cells, and you're fixed to a square world grid. Yes, absolutely. So that's what this like chapter was all about, is just doing that. So we've got the first part of our grid down. We've got the ability to create the grid. We've got the ability to add something into the grid. And so our unit is being added into the grid here. We're not moving the unit yet. And so then when it moves, we may need to like move it, like remove it from one grid and then add it to another cell. But that is going to have to be next time because I am out of time for this morning. So I figured this is going to be a few different streams for me to like get the full pattern in. But I think it's going to be really cool once we get it in there because I do have some ideas to prove that they're in the different cells as they move around, maybe change their colors so each cell can have its own color. And that might be really nice. So with that, I'm going to switch over to my ending screen. Thank you everybody for stopping by and watching this. I am doing these streams every single weekday morning from 7 a.m. to around 8:15 Mountain Time. I know it's not too terribly long, but I'm hoping that I can get a longer stream in on the weekend. If you want to get notifications when I go live, you can follow me on Twitch or follow me on Twitter. And with that, I hope that you have a great rest of your day, and I shall see you next time.